Welcome to another very exciting video of data unit. Okay, in this video we are going to talk about compression, what it is and why do we need to use that, and how many types of compression do we have. So first of all, what is compression and what do we need it for? Okay, simply compression, it means to reduce the file size, okay, or reduce the size of any digital file, whether that is just a picture, text, or movie or audio, whatever that is. Okay, why do we need to? We've gotten just different reasons for that. The first one is we have limited space on the secondary storage. Okay, so we want to fit immense data on limited physical drives and SSD. So it is really good to reduce the size of the file so we can place more and more data there. Okay, the next thing is bandwidth, okay, or internet bandwidth. If the file size is a lot, then it takes a lot of time, or it uses a lot of bandwidth. Okay, if the file size is smaller, then we can transfer data using a smaller bandwidth, and it does not use much network bandwidth. And transfer speed, okay, we want to reduce transmission time for buffer free streaming, specifically in videos and audios and things like that. Okay, we don't want our videos to have buffers, so that's why we just need to compress, and we need to reduce the size of our files. Mainly we have gotten two types of compressions, okay, lossless compression and lossy compression. Okay, lossless compression is a compression where just you reduce the size but data is not lost. Okay, you have the same data, the same quality, and you can just kind of generate the previous binary as well if you want. Okay, but overall the data size is reduced but nothing is lost. And lossy compression is the compression that when you just simply reduce the size of the file, you delete some data. Okay, so it is lost, so that's why it's called lossy compression. Mostly we just delete the data which is not perceived by human senses, okay, or human senses cannot understand that. So let's talk about that in detail, what it is. See, lossless compression, mostly that is the art of repackaging. Okay, we have gotten the same data, we just simply repackage them. Okay, a very great way to do that is just to reduce the file redundancy, okay, repetition. So redundancy, it means identifies when the exact same data is stored multiple times and replaces it with a shorter mathematical reference. Okay, so the same thing is repeated many times, we will just simply count them and we will just replace them with something shorter. Okay, or simply we'll keep the count of that. So mostly here in raw file we have gotten high redundancy, in compressed file redundancy is indexed. Okay, it means we have just found the data repetitions and we have just managed them somehow, so nothing is lost and we know where those data were. Okay, see, the example for that is run-length encoding. Okay, we can just use that in pictures, you can use that in images, text, or anything. Okay, so algorithm in action, run-length encoding, or RLE. So on text, okay, how does it work? If we have just some characters repeated, we will just simply count them and we will say how many times just that happens. Okay, for example, see here we have gotten this character and we will just combine the letters, and in our main file we'll just simply say that, yeah, 3 B's or 5 A's or 5 N's, okay, something like that. So the method replaces a run of identical consecutive elements with a single value and a numerical count. The efficiency, for example, okay, transforms a 17 character string into just 8 characters if you just count the repetitions. See another example here. For example, we have gotten 3 A's, 5 B's, 1 C, and 2 D's. Okay, so we will just simply store that like 3A, 4B, 1 C, and 2 D. So the length or the number of the characters is just reduced here. Okay, so that is run-length encoding with text. Then run-length encoding with images, okay, or with pictures. With pictures, if we have the same color repeated many times, so we will just not write those 24 bits for each one. Okay, we will just use it once and we will just write a number before that, yeah, how many times this is repeated. Okay, this is a simple example of only black and white or something like that. Okay, so here, for example, yeah, 4 whites are repeated, so instead of W, you can just write there, yeah, 5 W's. Okay, now that W can be just 24 different binary digits. Okay, so that works in pictures as well. So RLE only works if there are repeating patterns. If an image is highly complex and every adjacent pixel is different color, so they are just not repeated. Okay, RLE will actually increase the file size. How? So for example, there is one color, it will add 1 before that. There is just another color, then it will add 1 before that. So it will only add, okay, count numbers to single pixels. So as a result, we will have even just larger file size. But for the pictures which have just kind of repeated colors for many times, that is just a very nice way to do that. Okay. And when to use lossless compression, okay, when we have zero margin for error. Okay, if something is lost, everything will be just ruined and it will not work. For example, in source codes, okay, in programming languages or codes, a single lost or altered bit will corrupt the code syntax completely. Okay, and the complete software will crash and it will not work after that. Or in legal documents, okay, in legal documents where every character must be perfectly preserved, missing a single decimal point in a financial contract alters the meaning. So in legal documents, we do not want to just kind of do that. And in databases where we just need the exact and very accurate calculations, okay, so we have to use lossless compression, because if we lose anything, maybe just our result will be wrong, or it will be just kind of approximation, which is not acceptable in financial contracts or in any kind of database. Okay, so there are some examples where we can use lossless compressions. Let's talk about lossy compressions. Okay, what they are. This is the art of the unnoticed. Things which are unnoticed, we will simply remove them. Okay, so the process significantly reduces file size by identifying and permanently deleting data that human senses are unlikely to notice. Okay, so if something looks or sounds identical to us, we will just simply delete them. Okay, or we will just replace them with the same smaller version of something. Okay, you have to just kind of be careful about one. Lossy compressions are irreversible. Okay, so when compressed, the original raw data is permanently lost and it can never be reconstructed. Okay, the trade-off here is, okay, lossy compression achieves dramatically higher compression ratios than lossless. So it just compresses file much more. It reduces the size of the file much more, but simply it sacrifices technical quality. Okay, so that is something you have to just know about lossy compressions. Some examples, okay, for example, in the pictures, deleting the details. We have gotten a very high detailed picture, which is, for example, 6 MBs, okay, and it contains thousands of unique, slightly different shades of blue. Okay, maybe just they are not perceivable by human eye, or they are not detectable by human eye. Okay, so what will we do? For example, we'll create some algorithms that groups nearly identical colors into a single shade, so discarding the subtle variations. Okay, so this is good till the time that, yeah, for example, the colors that they are just merging, they are undetectable by human eye. Okay, so the human eye is pure at detecting slight color variations, making this massive data loss visually acceptable. Okay, otherwise if it changes and human eye can understand that, maybe it is not acceptable. Or for example, in audios, okay, MP3 audios, so it keeps the human hearing range files, and just other than that it removes other things. Okay, so perceptual music shaping removes frequencies completely outside human hearing, things that human cannot hear. Okay, those frequencies will be deleted. alongside quiet sounds that are masked by louder ones. Maybe we have just gotten some quiet sounds that louder sounds are just kind of masking them and we cannot hear them, because so it will remove that. As a result of this, we will have a 30 MB uncompressed WAV file reduced to a 3 MB MP3 file. Okay, so this is around 90% reduction in file size. Okay, and because human ear cannot kind of differentiate the difference much, so it is acceptable. Okay, so that is another example. And videos are just a real world ecosystem of compression. Okay, for example, see the movie video, the video of this, okay, MP4, that is lossy, heavily compressed to prevent buffering. Okay, so the repeated pixels in the same frame or in the same picture of the video, or maybe just in the repeated one, this frame and the next frame and the next one, they do not change, so we do not change them. Okay, so that is compressed, so this is lossy, we lose the data there. Okay, or the soundtrack, this is also kind of lossy. Okay, C or MP3. Perceptual shaping ensures smooth streaming, so we remove the data which is just not detectable by human ears, so the file size reduces and we have smooth streaming and no buffering. Okay, and the subtitles, okay, here if we are just applying any kind of compression, it has to be lossless. Why? Because every character must remain perfectly exact and legible and readable. If one bit here is just lost, okay, or one bit of data is lost here, the complete text will be unreadable. Okay, or for example, the app applications source code, so it has to be compressed with a lossless compression. Okay, why? Because if a single bit is lost in a source code, the complete application will crash and it will not work anymore. Okay, so this is just a real world example where many types of compressions are just done, and some are lossy and some are lossless. Let's just kind of compare lossless and lossy compressions in a table. Okay, so lossless compression and lossy compression, reversibility, are they just reversible? See, lossless compression is entirely reversible, we can just reverse it, but lossy compressions, because we just delete some data, they are irreversible. Okay, and the data is permanently lost. Is data removed in them? So in lossless compression, no, data is not removed, just we simply find redundancies or repetitions and we just work on them. And in lossy compression, yeah, data is removed. Okay, mostly we just remove unnoticed data. Compression ratio, how is it in both of them? In lossless compression, that is moderate reduction. Okay, but in lossy compression we have dramatic reduction. Okay, it means the file size is reduced a lot. Quality impact, lossless compression is perfect 101, it's just the same like original quality. Okay, no data is lost, nothing is lost. But in lossy compression, yeah, lower technical quality but acceptable to humans. Then common formats for both of them. Okay, for lossy compression, lossless compressions, we have gotten PNG, GIF, PDF, zip, where data is not lost. Okay, and they are just reversible. But in lossy compressions, for example, JPEG, MP3s and MP4s, okay, they are examples of lossy compressions. Let's test your knowledge. Okay, there are some questions, try to just think of the answer or write your answers on a piece of paper before you just read the answers in this video. Okay, you can just pause the video for each question and you can then compare your own answer with the answers in the video. So the first question is, state 3 reasons a company would compress video files before uploading them to a website. 3 reasons. Okay, pause the video, write your answer and come back. Good. See, the first reason, less storage space required on web server. That is very important. Less bandwidth required to transmit. So we will not use a lot of internet bandwidth as well, and we will not use a lot of storage space on the web server as well, okay, which is expensive. And the third reason, shorter transmission or download time for users. So your website will be just kind of faster. The next question, again, do the same, okay? Pause the video and write your answer, then come back, okay? A text file contains the string BBB, or just this string, okay? Perform or LE on this string. Do that. See, that is 3B, then 5A, then 5N, and 4D. So that is this kind of, we compress this lengthy text to this shorter one. And the next question, explain why lossy compression is suitable for a photograph but not for a computer program. 4 marks. Explain this. See, the reason is photos can lose slight color data because human eyes won't notice. So this is acceptable quality loss. But programs require exact data. If Lossy deletes a single line of code, the program will crash. Okay, not a single line of code even. If it just simply deletes one bit or one word from that, so the program won't work anymore. And overall, okay, the final thing about the compression, okay, that is the balance of the digital world. Compression is the silent engine of the modern internet. Every time you click, stream, or download, an algorithm is making a choice: perfect preservation or human perception. So it has to just kind of decide, do I need to compress it with lossless or with lossy, okay? And without compression, the massive data files won't be kind of operable on the internet. That's it. Do not forget to like and subscribe our channel. Wish you all the best. Good luck and goodbye. If there was any question, you may just put that in the comment section.